Hello. Today I'm going to show you how me and my teammate Matthew Smith, Matthew, please stop clapping. How me and my teammate Matthew Smith programmed teledrones to fly through at least one hoop. We have two, but today I'm just going to show you how we did it for one hoop. We're going to start off with, of course, my file management. As you could see from earlier projects, I have my repositories, my intros and outros for like videos like these, my pictures and videos for my Arduino board, and then my virtual machine, which if I delete that, half of my computer will stop working. But for this, I'd have to go to repositories, and you can see my Arduino board. You could see my code sandbox, our sonar, and our infotech center files. But again, for this video, we're just going to be focusing on teledrones. And here you'll see another set of 4 files. Wow. And we'll find video and a few other things, but for this, you could see videos, and we have second hoop stable and Matthew Corday hoop 1. Should say first hoop stable, but we decided to be um, fun with the names, I guess. And we did not make it that. But instead of having to load it up, I could just go ahead and do a little thing like this, where you could see our code on one side. This is the code that we use to get through the first hoop. And if you're doing this challenge at school or you set up your own hoops, this code probably won't work for you because of the fact that not everybody sets it up 227 centimeters away from their starting area. But this is the video of our code actually working. I don't know who that kid is. He's Zesty. But as you see, that's the video of our code working for the first hoop. I can, of course, show you the second hoop. This is our code for our second hoop. I'm going to go ahead and do a little thing called pausing the recording. Alright, and after my expertise of editing called pausing the recording, I now have my second hoop and my second hoop stable code up. As you can see, we had to keep the forward message, and then we used a thing called go command, which here it would make all these things happen pretty much simultaneously, where it would move forward 160 centimeters, or it would move up 160 centimeters. Nope, I was right the first time. Yep. It would move forward 160 centimeters while adjusting for our drone would like drift off a little like left, so we would make it go right while simultaneously going up 50 centimeters. And every time we had tried to run this code before, it would come up with low voltage or joystick error, which we learned that if we add an 8 here, it would affect the code after it. So there was no point in putting a forward 230, then comma 8. Instead, we should have put that, or yeah, then we should have put it there for this instead of putting it here. Like, we put the comma 8 here first, thinking that that would fix it, but then we realized that this 8-second wait so that it wouldn't be overloaded and say that the battery's just fried, even though it's not. Excuse me. It would instead actually run and not get overloaded and take an 8-second time wait on top of the original 8-second time wait. So it took a total of 16 seconds before it would continue. And as you can see in this video, you can see our code here, and then I'll show you the video of it running here. It goes up, it waits 8 seconds, and it takes off, stops a little bit in front of the hoop, just a little bit. And then here, you can see it's going up. It adjusted for the left. It didn't go left that time. So instead, it went right. And then it fell back down. And that's how we coded it to work. So it worked pretty well, and it got us to move on to the third hoop, of which we tried. But as of right now, we haven't been able to get it fully, like, correct and down. So that is coming in the future, hopefully, if we could learn how to make the curve code go correct. But that was our second hoop. And of course, here is the code all put together. If you want to copy the actual template for how we did it, if you're using the same drones or trying to do sort of the same thing, here is the template for it. You could just slow or pause the video at any of these times and just copy down whatever you see. I'm just going to scroll through it slowly. Now, this technically isn't, like, needed, but we have it here so that we know what, like, command message is going for which hoop. So this command right here works for the first hoop. This command right here works for the second hoop. We haven't committed it yet because it's not fully working and stable yet, but the third hoop would have a curve command said here. Second hoop, of course, would have a go command, which you could see we have right here. And this one just has a normal command, so we kept it go. Now this one, we'd change, or this one, we'd have to, I believe, make it go down. So we'd basically be able to copy this code into here, but turn this into a negative so that it would go down instead of going up. So this would be on the x-axis, this would also be on the x-axis, and this would be on the y and z axis. So the way you would have to think about coding and putting in the numbers is basically like a 3D shape, where you have two lines overlapping each other for the x-axis, and then you'd have the y-axis going up and the z-axis going down. And the z-axis would be our negative number for these two, which is pretty cool. Of course, here you could see we have 3 different branches. Now I'm going to be into my GitHub instead of Git Desktop. And this repository was made by my teammate Matthew Smith. Wow, look at that. And the 3 branches are the main, which right now shouldn't have anything because we haven't merged anything. The test, which is AF1, which we've moved off of the test and have now gone to the competition branch, of which we've been working on and actually sending our code there, where if you see, I could click on that, and we could see all of our code is here. And since the reason you can't see our curve code or our attempts for a curve code on here is because we have a secondary laptop, of which we also use Matthew's account to make our code, test our code, and continue doing it, of which then we would push it up to the cloud, where if I were to go here, this right here that says fetch origin would either say push or pull. If there was something new that was pushed by the laptop, we'd be able to pull it from here. If there was something that needed to be pushed from this computer, it would say pull on the laptop when we got onto the laptop. And as you could see, here it says that all this was committed by Matthew Smith, even though I mainly worked on the code for the Go and Curve code. And this is because since we mainly use the laptop, except for this one time for some reason. Since we mainly use the laptop to actually test and run our code, it looks like I'm not doing anything, but I swear I am. I truly do swear I'm doing stuff. Anyway, that pretty much sums up the whole Arduino drones as of right now. Of course, it'll be different. Like we'll actually have curve, and hopefully I'll have curve and all the other files and videos sent in. You can see we only have 2 videos right now, so hopefully there will be 4 later on. Oh, my bad. I'll cut that out. Hopefully there will be like 4 videos later on in our drones, or maybe we'll just do something else because Innovation Day is 14 days from now. Alright.